Hello guys, in today's video. Today I want to talk a bit about my power supply, which I recently upgraded from a small little boxy thing to a standalone device like that. It is still powered by a DC input, but right now it's more useful, I think. So let's get started with the thing. So what we have on the front panel is a switch that connects and disconnects the output. We have a switch that switches the power supply into constant voltage or constant current mode, and we will test it in a second. Then we have a voltmeter, and we have a knob for regulating the output voltage. And then we have the current regulating knob, which doesn't work in constant voltage mode. It just doesn't work. It does nothing. When we switch to constant current mode, the voltage drops to 0, and right now we can regulate the current like that. The maximum voltage in current regulating mode is 6.6 volts, 6.2, 6.3, it depends, but it's basically the maximum. So I will set my power supply in constant voltage mode to 5 volts, and let's start some measurements. So constant voltage, current doesn't do anything in this mode. Turn it on. You can see that it's pretty accurate. 5 volts, 5.4 volts, 5.8 volts, 5.9, 6, 6.1, 6.6. It can get up to 16 volts at maximum. As you can see, that's the maximum, 16.4, and it's not bang on with 16.04, it's 15.2 something, kind of okay accuracy. Here I have mounted an analog ammeter, as you can see. Let's put it back to 5 volts. Ammeter works in ranges of, as you can see, from 0 up to 1 amp, and it has 0.2 amp resolution. So voltage is kind of okay. Let's right now test the constant current mode. So let's switch my multimeter into a ammeter. And let's right now increase the current. And as you can see, ammeter shows right now nearly 0.4 amps here, and the meter shows nearly the same thing. And the voltage, in order to make 0.4 amps in short current, needs to be 0.6 volts. I can disconnect it, and as you can see, current drops and the voltage rises, because there's no current drawn. Okay, so you might say, in constant current mode I was changing the voltage and there is no difference. But let me show you one simple thing. Let's go pretty low with voltage, like 3.3 volts. And let's right now connect it to my ammeter. Boom, full current, 2.1 amps. Right now, let's do a different thing. Let's go to constant current and let's set it to maximum current. And right now I can very easily change the current. I think you can see the needle and the ammeter readings. That's the difference. Of course it becomes unstable when it will heat up. I will show you the insides in a second. But here I can change the current, and of course my ammeter turned off, fallen asleep. So that's the difference, that here in the constant voltage mode I can control voltage, in constant current mode I can control current, and those are the two differences. Right now I will grab an LED. I have a package full of LEDs. Let me grab one of them and let's get rid of multimeter And let's put the banana jacks into the power supply. Let's switch to constant current and let's switch it to 0. So right now we have an LED. The shorter leg is the leg that connects to ground, and the longer one is the one that connects to plus. And here you have a slight cut, as you can see. It's flat on one side, on the side that it is flat it's cathode, and this is anode. So we are in constant current mode, and look at the LED while I am turning the pot, the knob for current. That's something that I wouldn't be able to achieve with normal mode, because here I am fluently changing the current, not the voltage, so it sets itself to appropriate voltage level, and with this knob I can limit the current more or less. So that's the difference between the constant current and constant voltage mode. So let's right now open it up. Okay, so let's take a look inside. Here we got the thing. I just pull the case up, and this is what we see inside. Wire mesh to connect front panel to whole circuit, and then we have two things, which is this transistor circuit. As you can see, there is a lot of tape to prevent shorts, but that's the circuit that limits the current. It's just a single transistor that is here for limiting the current, or as I would like to call it, fluently control current. And then under this slice of tape, which prevents any shorts and heat sinks, we have the rest, which is LM317 board, and the same thing that you saw in pretty much all of my episodes. So the whole circuit is pretty simple. If someone will want, I can show, or I can post the schematics in a pinned comment. But the control of it is pretty simple. Constant voltage, this knob; constant current, this knob; and that's pretty much all of it. And on the output we have the voltage after the voltmeter reads the voltage after the modules, so after the transistor for limiting the current, or after the LM317 regulator. So in both modes the voltage measured by this voltmeter is true. Here we have an ammeter that measures the overall current drawn by this LED, this transistor circuit maybe, and all the other stuff. So it doesn't measure the current drawn by the voltmeter, but it measures current drawn by this LED and the transistor circuit for current control. So that's how it looks like on inside. On the back there is nothing, just the wire comes inside and delivers power. On the back I was trying to glue some stuff the first time, and then I thought I will just attach those metal pieces to elevate it a bit so it's a bit better visible when it sits on the workbench. And that's pretty much all of it. Right now we'll do a load test. Okay, so that's our setup. I have connected the electronic load to the output of the power supply in series with ammeter, and right now on the constant voltage mode I will set 10 volts. This will be the voltage of our tests, because I think, or let's maybe do 12 volts, because that's the most common highest voltage that you'll be using with some modules. So we turn it on, and let's see from which point it starts to drop current. So we reach 1 amp and then it starts to drop current. So that's why I've written here 16 volts 1 amp, because the power supply starts to drop voltage after 1 amp. So let's right now switch to constant current mode, and let's I should switch it off, then to constant current, and then connect the output. So let's see, let's set my load here and let's start to deliver the current to the load. Voltage is, I believe, too low to trigger my load at all. Right now we are delivering some current, and at maximum we deliver 119, and half an amp is like a maximum at 4.6 volts for the current limited mode, because here the fluent current can be set like 35 milliamps, 100 milliamps, half an amp, and that's it. And that's the maximum. At half an amp in constant current mode and constant voltage, it's 2.5 amps even. But voltage is stable on 1 amp maximum, and that's, I think, the voltage on which it should be operated at. So this is a small upgrade, nice for testing LEDs, as I showed you. Nice feature to have a constant current mode in your power supply, because it can be useful sometimes. But when you're using a linear current limitation by a transistor like I am doing here, which is just a potentiometer connected as a voltage divider to the gate of the transistor inside, and it dissipates pretty much the heat on its own on the heatsink. If you're doing it this way, you need to remember that the current dissipation, the power dissipation will be pretty high. So that's why I have big heatsink inside. So that's pretty much the whole circuit. I hope you enjoyed it, and see you next time.